Hi guys, good morning. I did this video because the other one wasn't able to download for some reason for some of the students. So all I did was just went over the very first section for Plato. So we always start by going to Clever. So we go to Clever and you guys log in. Yours should look different than mine. Remember to log in with Google because I have mine as a teacher. Once you log into Clever, then you would scroll down until you see the E for Edmentum. We log into Edmentum, and again, remember, yours looks a little bit different than mine because I have my classes assigned. Then you would look for your geometry class. Once you go to your geometry class, then you guys can click on it and it's going to give you something that looks like this. Okay, it's going to give you your sections, it's going to give you titles, it's going to give you tutorials, and it's going to give you the mastery test. Okay, before you take your mastery test, make sure that you guys follow the tutorial. So we're going to click on tutorial and we're going to work on this first section together, and then maybe you guys can, if you have any questions, you can still email me, or we can just make another live session. So for example, on this one, the first one is just going to be a video and it's just going to tell us just in the course what it is. Okay. Make sure that when you're going through Plato, you click on everything and you let everything play. We move on to the second one. This one is just explaining that it's just a tutorial. The third slide just tells us our objective, what you guys are going to learn on the section. It gives us a brief introduction. It talks about area and circumference of circles because we are going to be using those. And then it starts with our very first activity. Now, again, if you guys do not do all of the activities, it doesn't clear you guys. It doesn't tell you that, it doesn't give you guys a grade for that section. It says that it's not completed. So make sure that you guys complete every single activity that there is within the tutorials. And we're going to scroll down on this one. It says Activity 1, Question 1. You will use the GeoGebra geometry tool to look for a relationship between the circumference and the diameter of a circle. Notice how it gives you a link that you can click. So we're going to click there. Okay, and it gives me a circle. It says rolling a circle to find pi. Okay, now if I keep on scrolling down, it says move the slider to roll the circle. As you roll the circle, the circumference of the circle unfolds along the x-axis and the length of the circumference appears below. Once you've completely rolled out the circumference, fill in the table for the specific diameter used. So this is the table that we're going to be filling out. Okay, so the first thing we go back to our activity. We're going to click on this little blue circle and notice how I can change the diameter of the circle. Okay, so let's start with this number right here. I'm trying to get it exactly at 2. Okay, so if my diameter is 2, now I'm going to roll the circle. Notice how it's expanding. There, that means that my circumference is 2.68. So I'm going to go back and I'm going to fill out my table. So when the diameter is 2, the circumference was 6.28. Okay, then it's asking me for the ratio of circumference to diameter. So what I'm going to do is I am going to divide, the circumference comes first, so I'm going to divide the circumference by the diameter. Okay, so I have my calculator and we divide the circumference 6.28 by the diameter, which is 2. So the ratio is 3.4. So I'm going to put 3.14. Okay, I'm going to do that 5 times. Now I'm going to go back again. And I'm going to change the diameter. So let's try 3 now. And it doesn't have to be whole numbers. You guys can pick decimals. That's totally fine. It's up to you. If I pick 3, when the diameter is 3, the circumference is 9.42. That means that everything around this circle measures 9.42. Okay? So diameter is 3, 9.42. Let me just double check. Yes, that's correct. Now we get our calculator again. And we're going to put, remember, circumference comes first. So 9.42 divided by 3. Wow, again, 3.14. So we're going to do this until we fill out the whole table. Once you're done filling out the table, then you can move to the second part. What relationship between the circumference and the diameter is suggested by your observations? If you notice, we have seen 3.14 before, okay? And that is our pi. So then you can put that the relationship between the circumference and the diameter will always be the same, 3.14. Which in math, we know it represents pi. Okay, and that's it. So it's not that complicated, guys, but you have to go through it. You have to read every single detail that they have and use all of the things that they want you guys to use. So for part C, it says the number 3.14 is rounded to the value for, we already said it, pi. What is the exact formula for the circumference in terms of the diameter? Okay, so now it's asking you, when we have circumference, and we should already know this because we covered it a while back. When I want to find circumference, circumference equals the diameter times pi. I don't know how to get pi here. Let me see if I can do this one. Yay. So circumference equals diameter multiplied by pi. Okay? And I can just delete this. Okay? So every time that I want to find the circumference, I must multiply the diameter times pi. Now it also says, what does that mean in terms of the radius? What if they didn't give me the radius? What if they didn't give me the diameter, but they gave me the radius? So for that, remember that I gave you 2 formulas for circumference. The second formula I gave you was 2r pi. Okay, so remember the diameter is just going to be 2 times the radius. So if I don't have the diameter, then I can multiply the radius times 2 and then just multiply times pi. Okay, and then you would just explain that in words. The next question is asking you, as you increase the number of dissected parts, the shape they form begins to resemble a geometric figure. Which figure does the shape resemble? Okay, and what that means is when we're working with this, and I think they give you another one. Let's go check the other one. Okay, here it is for the area of a circle. Okay, they're telling me straighten the circumference. So look at what's happening. You're rolling everything that is around the circle. I'm straightening it out. And what shape does it make? It forms a straight line. So we are extending it all the way until it forms a straight line. Okay, so that would be your answer to question number 2. So if I'm looking at in terms of area, is everything that is going to be enclosed, everything inside of that circle, the area, everything inside. So remember, the circumference was just the line around it. The area is everything that is going to be inside of that circle, everything inside of that line. Now, when we get to this slide, again, they're giving you a lot of information, so make sure you guys read it. I'm just going to make it a little bit simpler for you for this one. It's just giving us our two formulas, circumference 2 pi r, area pi r squared. Okay, and then it comes to a first question. It says the diameter of a circle is 2 times the radius. We already know that. Which equation is another way to represent the area of a circle? Okay, so very important. We looked at our previous slide and we saw that the area of the circle was pi r squared. Notice how none of my answer choices have the radius, okay? But we did learn that the diameter, is 2 times the radius, okay? The diameter is 2 times the radius. So if I have diameter and I want to find the radius, remember you have to divide the diameter by 2, and that's always going to give me the radius every single time. So what I'm going to do is I'm going to plug in this into my formula in place of the radius. Everything else is going to stay the same. So I'm going to have area equals pi, in parentheses, I'm going to put diameter divided by 2. The formula says to square it, and that's going to be the area of a circle. Now notice how it does not match yet. From algebra, we know that every time that we have an exponent outside of a parentheses, every single time that we have an exponent outside parentheses, it must go to the top and it must go to the bottom as well. So let's simplify our equation. Pi diameter squared over 2 squared. Okay? Now, diameter squared is going to have to stay the same. So the d is going to stay the same. And on the bottom, I have 2 squared. So 2 squared is going to be 4. The only one that matches would be the second one. So again, it's not that bad. It does require you guys to think a little bit more. And you do have to take every part of notes that they give you into account so you guys can do your answers correctly. Now, the good thing is that your tutorial matches your test. So if you're really, really good with this, then you should be really good on your test and you should be completely fine. So let me erase this and then we'll move on to the next one. Okay, sorry. Computer is being a little slow, but it's okay. Okay, then we move on to the formulas for volume. Okay, every time that we do a volume, that means we're taking into account everything that fits inside of that 3D shape or that solid. For volume, our main formula is going to be length times width times height for this figure because the base is a rectangle. So the formula for volume, the basic formula for volume is the area of the base times the height, okay? The base on this case is going to be a rectangle. That's why we put length times width. That's the area of the base. And then we multiply times the height of the solid. Okay? Make sure that you guys are writing these so you guys can use them for your mastery test. Let's move on to the next one. Volume of formulas. We're still under volume of formulas. For a cylinder, notice how a cylinder, the base of the cylinder is a circle. Okay, so the volume is still the area of the base times the height. The area of the base times the height. Just don't forget that the area of a circle is going to be pi r squared. Okay, so that's something you cannot forget, pi r squared, and then you would multiply times the height of the cylinder. So a lot of reading, now that you don't have me to talk to you guys and just be blah, 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 talking the whole class. Now you have to read on your own, guys, but it's the exact same thing. Okay, so we come up here, we have our first example. And again, I told you guys practically the answer to this question. So for the volume, we have the area of the base. My base is a circle. So for volume, we have the area of the base. And I'm going to multiply that times how tall the cylinder is. Okay, so what formula represents the volume of the cylinder? And the only one that matches is this one right here. So not too bad. Okay, let's keep on going. We're almost there. Now then it starts talking about our cylinders. When they're slightly slanted, what happens to them? Okay, if the radius stays the same, if the height stays the same, then the oblique cylinder, it's called an oblique cylinder because it's just slanted. It's not straight up and down. It's a little bit slanted. If the radius is the same, the height is the same, it's going to have the same volume. So we can use the same formula as we did before. So the volume is still going to be the area of the base times the height. Our area of the base is still a circle. So it's still going to be pi r squared. And the height, please make sure that we use the height of the cylinder, not the side of the cylinder, okay? That's going to be very important for oblique cylinders. Let's move on. Next question. Okay, so now we have volume of oblique cylinders. And again, remember, every time that we have one of these activities, you're going to have to click on the slider and then you guys can answer your questions. Okay? I click on it and it's going to give me an oblique cylinder. It's always going to give you something to work with. Okay? Notice how you can change this. Okay? Okay? As long as the height stays the same, the volume will always be the same. As long as the height stays the same, the volume would be the same as if it's a straight or oblique cylinder. Very, very important. Then go ahead and answer your questions. Then we move on to the next one. This one is talking about Cavalieri's principle, which says that if two three-dimensional figures have the same height and have the same cross-sectional area, which means your base has to be the same, then the volume is going to be the same. The volume is going to be the same for both. So very important again. I'm looking at both cylinders. They don't look the same, that they would hold the same capacity, but because the base is the same, the radius is the same length, and if they have the same height, okay, they're gonna hold the same capacity, because remember, our volume is the area of the base times the height. Doesn't matter if it's an oblique or if it's a straight cylinder. If they have the same height, if they have the same radius, then they're going to be holding the same volume. So important to know. Then we move into cones. Okay, for cones we have another activity, and we're going to click, they give me two links, one for the volume of a cylinder, one for a volume of a cone. The first thing that we have to do is we have to look at the radius and height of the cone. I have to look for the radius and height of the cylinder, and then the volume of each. Now notice how they have to be, there's only one space for radius and height, so that means that I have to place the radius and the height for both has to be the same. So I'm going to click on the first one, and it's my cylinder. So I'm going to make sure that I'm going to do the radius of 6 and a height of 11. Radius of 6, height of 11, and then this would be my volume. Okay? So radius of 6, height of 11, and then I go back to my, whoops, that's a cylinder. Volume of a cylinder, and it's 1244.07. 1244.07. Then I do the same thing for a cone. So now I'm going to open the cone, the link for a cone, and then I'm going to put radius of 6, height of 11. Okay, very important that it's the same. Radius of 6, height of 11, okay, perfect. Radius of 6, height of 11, it matches my cylinder. And now the volume for this one is 414.7. Okay, and then the last thing they want you to find is the ratio of volumes. So for the ratio of volumes, they tell you right here on the top, divide the volume of the cone by the volume of the cylinder. So I'm going to divide the volume of the cone, 414.7, divided by 1244.07. Press enter, and I get 0.33. Okay, now we don't have our fancy calculators to turn decimals into fractions. So what I want to do is, I'm just going to go ahead and give you guys a fraction. So the fraction that it approximates to is going to be 1/3. Okay, 0.33. So you're going to fill out your whole table with different radiuses, different heights, the volumes, and then the ratio. The ratio will always be the same, 1/3. The volume of a cone will always be 1/3 of the volume of the cylinder, every single time. And then you guys move on and you guys keep answering your questions. And we move on to the next section. Okay, no surprise. The next section explains us our formula for the volume of a cone. And the volume of a cone is going to be 1/3 of the volume of the cylinder. Okay, and remember, we talked about the volume of the cylinder. The volume of the cylinder was the area of your base, so pi r squared, times the height of the cylinder. So now for a cone, we have to put 1/3 the area of the base times the height. That's for the volume of your cones. So your volume of your cone is still going to be pi r squared times the height, and then don't forget the 1/3. So not that bad, not too complicated. Okay, then we go to the pyramids. For volume of the pyramids, then we have another activity. So they want you to discover all these things on your own by doing a lot of activities. Okay, we have another table just like we did before. So you're gonna do the same thing as I did with the cylinder and the cone. Okay, it's gonna ask us for the ratio. Notice how we have a ratio here. So no surprise, we can already guess what it's gonna be. Okay, the volume of a pyramid will be 1/3 the volume of a cube. Okay, that takes us to our next formula. Okay, so no surprise again. Our base for the pyramid is still a rectangle. So our base is still a rectangle. So I'm still going to do length times width times the height. The only difference is the area of the base here times the height. The only difference is that the volume of the pyramid is just going to be 1/3. Okay, 1/3 of the volume of the cube. So let's erase this so that we can move on. We're almost done. Okay, and then it brings us to one of these questions. It says if a pyramid has a square base, remember squares, all of the sides are the same. So our base is a square. It doesn't look like a square, but they're telling us it's a square. So we're going to take their word for it. The base of the square with lengths of s and height, very important, the height is h. Which formula represents the volume of the pyramid? Okay, remember we said our volume for a pyramid has to be 1/3 the area of the base times the height. Give me 1 second. Do that and do that. Do that in purple. The area of the base times the height. Okay, now volume stays the same. The 1/3 is going to stay the same so far. The area of the base, remember we do length times width, so that would be s times s. And then the height is just letter h. There's no number there. Okay, again, we have to keep in mind always our algebra. The 1/3 stays. From algebra, we know that s times s should be s squared. And the h stays the same. So notice how the only one that matches would be that one. So that's going to be our answer. Let's move on. Okay, Cavalieri's principle. Okay, for three-dimensional shapes, it's going to stay the same. It also works for pyramids and it also works for cones. So just like the oblique cylinder, if I were to take this pyramid, if it has the same base, if the pyramid has the same base as this pyramid, okay, and they share the same height, this pyramid is a straight pyramid, this one is one that is slanted, it does not matter. As long as the base is the same, as long as the height is the same, then both of them will have the same capacity. They're going to hold the same volume. The same thing goes for cones. If a right cone has the same radius, this one's important, has the same radius as this cone that is slanted, if they have the same radius and they share the same height, the volume would be the same. Doesn't matter if the cone is slanted or not, as long as they have the same radius for their base, as long as they have the same height, the volume will be the same. So something to think about. Keep that in mind when you guys are taking your test. And then finally, it gives you a summary with a list of all of your formulas. Make sure you have all of your formulas down so that you guys can use them for the test. They're going to be important. And that's going to be it, guys. If you guys still have any more questions, please go ahead and email me. And have a good rest of your day.